Hey guys, so we're going to take a look at acids and bases today, and this is topic 3 of Unit 3 in our environmental chemistry unit. So the first thing that we need to learn about as it relates to acids and bases is this thing called the pH scale, and you may have heard of this before, but I don't think it's really ever been covered in science classes previous to Science 9 for you guys. So we're going to take a look at just some basic concepts as it pertains to the pH scale. So the first thing you need to know is that the pH scale runs on a scale of 0 to 14. And I've got a diagram down here below that just kind of shows that we've got kind of pH 1 here is where we have some really strong acids, and pH 14 is where we have some really strong bases. Now, the thing that makes the pH scale kind of unique from other scales, like say temperature or say the Richter scale, the scale used to measure earthquakes, is that usually when we have these scales, the small numbers mean weak and the large numbers mean strong. Or in the case of temperature, small numbers mean cold, large numbers mean hot. On the Richter scale, it's the same thing. A small number means a really small earthquake, and a large number means a really large earthquake. But on the pH scale, it actually starts here in the middle, where we have a pH of 7, and this is what's considered a neutral pH. So something like pure water would have a pH of 7. And then as we move away from 7 towards the left, down towards the smaller numbers here, this is what's referred to as the acid side of the pH scale. So you can see here I've written anything that has a pH of less than 7 is considered acidic. Now, the things that are most acidic are going to be the things that are furthest away from 7. So over here, pH of 1 and 2, these guys are going to be much stronger acids than things that have pH of 5 or 6. The same is true over here for bases going the other direction. So you can see again, if I move away from 7 but towards the right, now I'm in the base or the basic side of the pH scale. So you can see I've got written over here, any substance that has a pH greater than 7 is considered basic. And so what this means is that anything that's got a pH of 13 or 14, these guys are very, very strong bases. And anything that over here has a pH of 8 or 9 is going to be a lot more of a weak base compared to these bases over here on this side. So that's how the pH scale really works. And something else that you need to know as it relates to acids and bases is this thing called a litmus test. Now, litmus paper just reacts with acids and bases really well, and it's designed to give a color change. So all you need to know for this is that when we're testing litmus paper in acids, so substances that have a pH of less than 7, the litmus paper is going to turn red. And so you can see here in this diagram, I've got a blue litmus paper, and if I put a drop of acid on this blue litmus paper, you can see that the litmus turns red. If I were to have a red litmus paper tested on an acid, then the red litmus paper would just stay red. There would be no color change. Also for bases that have a pH of greater than 7, because that's where they're found on the pH scale, these guys are going to turn litmus paper blue. So you can see this red litmus paper here was tested with a base in this area, and it turned the red litmus paper blue. So I've got it kind of just narrowed down to some pretty basics. Acids turn litmus paper red, bases turn litmus paper blue. And that's all you got to know for these types of tests. Now, there are other indicators that are out there, and you'll learn more about those as you kind of get into high school. But one that we'll kind of touch on a little bit in Science 9 is this one called red cabbage juice. So this is actually or purple cabbage juice. So what you can do is you can take some purple cabbage, you can boil it, and you can get this purple cabbage juice or red cabbage juice, whatever you want to call it. Some call it purple, some call it red. And what you can do is this is actually a pH indicator. So you can put drops of this in a particular solution that you're trying to test, and the purple cabbage juice will turn that solution a different color. And depending on what color, or depending on what its pH is, will depend on what color it changes. And so that's kind of neat that you can kind of use that to indicate certain pH levels of certain substances. Now, another thing that's important as it relates to acids and bases is understanding how they form, because in our atmosphere, due to factories and the industrial age that produced a lot of these factories, we have a lot of pollution that goes up into our atmosphere. And these carbon, nitrogen, and sulfur oxides, what they do when they get up into the atmosphere is they react with the moisture, the water vapor, that's in the atmosphere. And if you get enough of those pollutants in the atmosphere, then enough of those pollutants will react with the water to produce enough acid that it will actually fall down to the earth as rain. And you've heard of this term acid rain before, but that's how they're formed, is these types of oxide compounds, carbon, nitrogen, and sulfur oxides, react with water to produce acidic precipitation. And so this is not good, because if you have acid that falls into lakes or even onto the soil, there's living things that use those areas as their ecosystems. And dropping pH levels away from neutral is dangerous, because most living things can't live in conditions where they're harsh, acidic, or basic conditions. They usually need those conditions to be very, very close to 7, which is neutral. And so you can see how sometimes acid rain can have a real negative effect on the environment. Acid is also a very, very good solvent, which means it can dissolve things really, really well. And so you get this water that gets into the soil, that's great, but if it's acidic water, so it's an acidic solution that has a pH that's really low, it will actually also dissolve some really valuable nutrients in those soils and then wash them away. And then you get things like this, where you have nutrient-deprived soils that can't harbor plant life. And so you can see this area here has really suffered because of acid rain. And then lakes and things like that as well. Fish really do not do very well in lakes where pH levels have dropped below 7 very far. And so this is not good. Another negative impact that acid rain has is because it's a solvent, it can also dissolve heavy metals. And if it can take those heavy metals with them as they flow to water systems, these heavy metals can get into the water systems. Those heavy metals can be taken up by other plants and animals, and then as humans harbor those to produce food and things like that, then we have heavy metals in our food, and heavy metals are poisonous to all living things, including humans. And so this is just not an ideal situation to have. So watching our pollution production and how much we put into the atmosphere is a real important thing. In a place like McGrath, we really don't see much acid rain because we just don't have that amount of pollution that exists in larger cities like New York City or Los Angeles, or if you've ever been to another really large city in the United States, or even Toronto. You see a lot of this smog that just kind of lingers in the atmosphere. And it's just because there's lots of cars that are being driven, lots of factories that are producing and doing their thing. And that pollution, as it mixes with the humidity in the air, produces acid rain. And those large city centers do deal with acid rain on a large scale on a consistent basis. And so this is something that they have to watch out for. The last thing that you need to know is just this real basic chemical reaction here as it relates to acids and bases. Now, what we can do is we can take an acid, react it with a base, and we can get these neutral substances. And so what's nice is that if we do have something like, say, an acid spill, like, say, a train falls off the tracks and you have this stuff that's fallen on the ground, instead of getting a digger in to come and dig up all of the soil that's now been contaminated, what we can do is we can take a base that's of equal concentration but opposite on the pH scale, and it will actually bring the pH levels back to neutral. And so it's sort of a natural way where we can take harmful substances, use other harmful substances to create harmless substances in the environment, and so that really helps. This reaction here you just need to have memorized. I'd write it down in your notes so that you've got it, so that's something that you can remember to study for the quizzes that are coming up. And if I just jump back here to this pH scale to just sort of illustrate, if I had an acid with a pH of 1, I could mix that with a base of a pH of 14, and that would bring that resulting solution right here to the neutral side, or to the neutral place on the pH scale. So that's what you guys need to know about acids and bases. Hopefully this was helpful. Thanks for watching.